Today we'll discuss latent heat, how we define this term latent heat. So latent heat, it is amount of energy required to change state of the substance without change in temperature. So how much energy you supply to the object so that you're changing the state, and whenever there's a change in state, the temperature of a substance does not change. So the moment when we provide energy and the object changes state, that amount of energy is simply known as the latent heat. Example, you have a solid. Say its temperature is 0 degrees centigrade. It can be any solid, but example, this solid is having a temperature 0 degrees centigrade. What you are doing, you supply heat energy. So when you heat this solid, what will happen to this solid? This solid will turn into a liquid state. So when this solid is turning into liquid, what will be the temperature of the liquid when, or what is the temperature when solid is changing into liquid? So temperature does not change. If solid temperature was 0, what will be the temperature of the liquid when it is changing the state? The solid is changing the state. The temperature of the liquid will also be 0. So because whenever there is a change in state, there is no change in temperature. So you are supplying energy. Example, you supply 2000 joules of energy. You supply 2000 joules of energy so that this solid is turning into liquid. So amount of energy which we supply to change the state, that amount of energy is known as latent heat. So the simple definition of a latent heat, it is amount of energy required to change the state. So how much energy required to change the state? You simply call that as latent heat. Is it clear, the concept of latent heat? Simply the energy required to change the state. Same thing if you have a container which is filled with a liquid, and you supplied heat energy. So substance is there in a liquid state, and this substance, when you are supplying the heat energy, it is changing into gas or vapors. Example, if a temperature of this liquid was 100 and the temperature at which the gas is formed, that will also be 100. So how much energy you supply? Example, you supplied 3000 joules. So you supplied 3000 joules so that you are converting this liquid into gas without there's a change in temperature. So amount of energy which we supply to an object, to a state, so that it changes from one to another, we simply call that as latent heat. Now the question is, we are supplying the energy, but why there is no change in temperature? Because what happened in a solid, the particles are tightly packed together. So what happened to the energy which you are supplying? Why there is no change in temperature even though we are heating a substance? Because what happened, the energy which you are supplying is breaking the bonds or attraction within the molecule. Because the molecule, the particle have attraction. So when you supply the energy, actually the energy which you supplied is used to break these bonds. So when energy supplied is used to break these bonds, that's why you don't observe any change in temperature. So whenever the substance is changing the state, the temperature will not change, or the temperature will be constant. So example, if you have a melting ice, so what will be the temperature of the melting ice? It will be constant. It will not change because it is changing the state. If you have a boiling water, what will happen to the temperature? It will also have a constant temperature. So whenever there is a change in state, there is no change in temperature, and energy which is supplied to change the state, the energy which is used to supply, or energy which we supply to change the state, we call that as latent heat. Is it clear, the concept of latent heat? Take the screenshot. The temperature will start to increase once all of the solid is converted into liquid, and now you have all liquid. So when you have all liquid and you supply heat energy to this liquid, then the temperature of the liquid will change. So when state is changing, temperature does not change. When state is not changing, the temperature will change. Like example, you are heating a container filled with water. When you supply the heat energy, the water, if it's water is not changing the state, it means the temperature of the water will change. So basically heat can cause a change in temperature, or heat can cause a change in state, but it cannot cause both things at the same time. So when I'm supplying heat energy, heat can change the temperature or heat can change the state. But if heat is changing the state, it will not cause a change in temperature. And same thing, if heat is causing a change in temperature, it will not cause a change in state. The two things of, or two processes which are related to heat cannot happen together. Either by supplying a heat energy, you can change the state or you can change the temperature, but both of them will not happen together. Like it will not happen, you're supplying heat energy, a substance is melting, and at the same time temperature is changing. That's wrong. This will never happen. So example, you have 3 kg solid, and you supplied 3000 joules. The temperature of the solid was 800 degrees centigrade, and we observe it turned into liquid. So it turned into liquid. What will be the temperature of the liquid when the solid is melting? When you're supplying heat energy, solid is melting. What is the temperature of the liquid? The temperature of the liquid will also be same, 800 degrees centigrade. So if a question is, what is the latent heat here? Latent heat means amount of energy required to change the state. What is the latent heat? So latent heat is 3000 joules. So the amount of energy which we need or required to change the state, that's equal to 3000. But if I say specific latent heat. The term specific latent heat means it is amount of energy required to change state of 1 kg object without change in temperature. So if we are finding how much energy is required for 1 kilogram or 1 kg, so 3000 is required for 3 kg, but how much energy is required for 1 kg? So that's equal to 3000 divided by the mass, which is 3. So 3000 divided by 3, what we will get? We will get 1000 joules per kilogram. So for every kilogram, for each kilogram, we need 1000 joules. So latent heat is energy required to change the state, but specific latent heat means energy required to change the state of 1 kilogram object. And to find the specific latent heat, the formula is specific latent heat is equals to the heat or energy divided by mass. Latent heat you can denote by L. Latent heat can be denoted by L. Energy you can denote it, represent by E, and the mass is M. So latent heat is energy divided by mass. And the unit, as we know, the unit of energy is joules, and unit of mass, SI unit of mass is kilogram, joule per kilogram. Is it clear the difference between the latent heat and specific latent heat? The difference between the latent heat and specific. Latent heat means total energy required to change the state, and specific latent heat means energy required to melt or to change the state of 1 kilogram object. Take the screenshot of this. Look, the difference between the latent heat and specific latent heat. Latent heat is means the total energy required to change the state. Example, you have 3 kilogram object and you supplied 3000 joules so that you melt all this 3 kilogram solid into liquid. So how much energy is supplied to melt all of the substance? That is called latent heat. But specific latent heat means how much energy is required to change the state of 1 kilogram object. That's called specific latent heat. So as you know, energy which you supplied is 3000, and how much it is changing the state? It is changing the state of 3 kilogram object. But you need a specific latent heat. Specific latent heat means energy required to change the state of each kilogram or 1 kilogram object. So 3000 is for 3 kilogram. So it's 3000 divided by 3, which means you need 1000 joules for every kilogram to change the state. So 1000 joule per kilogram, what does it mean? It means you need 1000 joules for each kilogram so that it will change the state. Is it clear? I'll give another example. Say you have a container which is filled with water originally. And the water temperature is 20 degrees in the beginning. You supplied heat energy. Say you supply 500 joules. And you observe the water temperature changes from 4,500. You observe the water temperature changes from 20 to 21 degrees centigrade. Is this a latent heat? So it's not a latent heat. Why it's not a latent heat? Because there's no change in state. Now, so this is not a latent heat because for a latent heat, there should be, yeah, this can be thermal capacity. That's right, thermal heat or thermal capacity. If there is a, like how much energy stored for 1 degree change in temperature. But this can be thermal capacity, but this is not latent heat. Now, if you have a container which is filled with water and the temperature of the water is 100 and you are supplying energy so that this water is converting into vapors. What will be the temperature of these water vapors? The water is converting into vapors. What will the temperature of the water vapors? That's also 100 because they're changing the state. That's why there's no change in temperature. You supplied 4,000 joules. You supplied 4,000 joules to this 2 kilogram water. So if a question is, what is the latent heat? So what is the latent heat here? Latent heat means energy required to change the state only. So it can be any object. So latent heat is 4,000 joules. But what is specific latent heat? So specific latent heat is energy for each kilogram. So because this is 4,000 is for 2 kilogram, but you need for 1. So 4,000 divided by 2, that's equal to 2,000. And the unit is joule per kilogram. So you need 2,000 joules for each kilogram so that you can change the state. So latent heat is energy needed to change the state of whole object, but specific latent heat is energy required to change the state of 1 kilogram object or 1 kilogram material without change in temperature. Is it clear? Then latent heat can be, or specific latent heat, both have the same formulas, specific latent heat and of fusion and vaporization. Because the change in state can be from solid to liquid, or it can be from liquid to gas, or gas to liquid. So if there's a change in state from solid to liquid or liquid to solid, that specific heat is known as specific latent heat of fusion. If a solid change to liquid or a liquid change to solid, we call that as specific latent heat of fusion. Concept is the same. It's energy required to change the state of 1 kilogram solid into liquid or 1 kilogram liquid into solid. And if there is a liquid change into gas, what we call that as specific latent heat of vaporization. So it can be specific latent heat of fusion or specific latent heat of vaporization. So what does it mean? If a solid, you have a solid, 1 kilogram solid, so if you have 1 kilogram solid and you're supplying heat energy, so that it is converting into liquid, or you have a liquid, you're removing the energy from a liquid so that it will convert into solid, the energy which you supplied or energy which, because for solid to liquid you have to supply energy, from liquid to solid you have to remove energy. So amount of energy which you supply or amount of energy which you remove from 1 kilogram liquid change to solid or 1 kilogram solid change to liquid when you supply energy, we call that as specific latent heat of fusion. And the formula is the same. Both latent heats can be calculated, or specific latent heat is energy divided by mass. And if you have a container which is filled with a liquid, you have 1 kilogram liquid, how much energy is supplied to this 1 kg liquid? So that it will convert into vapors. So that is called a specific latent heat of vaporization. The formula is same. It's energy which we supply divided by mass, because we are finding for each kilogram. So only distinguish, just to distinguish the states, like if solid is changing into liquid, we call fusion, specific latent heat of fusion. If liquid is changing into gas, we call that as specific latent heat of vaporization. Is it clear, the idea, the difference between the two? They have the same formulas, they have the same unit, only we use a different term for both. If it's solid change to liquid fusion, liquid change to gas, we call that as vaporization. Now some questions we will solve related to specific heat and latent heat both. Example, in this question, when a water is boiling, the thermal energy is supplied at a rate of 920 watts. So power is given. The specific latent heat of vaporization is 2.3 exponent 6 joules. Calculate the mass of water that boils away in 5 minutes. So specific latent heat of vaporization means a liquid is changing into gas. So what is the formula for, you can write this formula, latent heat or specific latent heat, all are denoted by L. So latent heat or specific latent heat, capital L, is equals to energy divided by mass. That's a formula. So we need mass, but the problem here, we have the latent heat. We have the latent heat, we need a mass. And we don't know the energy also. So how to use this formula if two unknowns are there. So first we have to find energy. How to find energy? Yesterday we discussed, when we use heaters, the power or energy supplied is equals to power of the heater multiplied by time. So what is the power here? The power, it's given 920. And how much time it is used? It is used for 5 minutes, but time should always be in second. So it will be 5 multiplied by 60. What is the answer here? 920 multiplied by 5 multiplied by 60. 27,000, 276,000. Okay. So energy, so we have the energy which is 276,000. Now that's in joules, but we have to find the mass. So we have the formula latent heat is equals to energy divided by mass. So latent heat is given 2.3 exponent 6. Energy is given 276,000, and we need a mass. If this mass is divided, other side it will be multiplied. So the cross multiply these two values. So what will be M? M is equals to 276,000 divided by 2.3 exponent 6. What is the answer here? .12. So 0.12, and because if this was given in kilograms, so the final answer will be in kg. So 0.12 kg. Is it clear, this question? So latent heat is energy divided by mass, but the question in this question we don't know the energy. That's why first we got to find the energy, which is power multiplied by time. So when power and time multiplied, we'll get the energy, and we'll use the formula latent heat is energy divided by mass. So we find the mass, which is energy divided by latent heat. The temperature and time graph for the wax is given. Use a figure, determine the melting point of a wax. This is a cooling curve. A wax is cool down. So here it is in a liquid state. Here we'll have both liquid and solid. And when the temperature start to change, it will be solid. So what will be the melting point? Freezing point and melting points are the same thing. Actually, it's a freezing point here, and that is also same as. So when we work out, so if I zoom into this graph, when the temperature is constant, it shows there is no change in state. So when temperature is constant means there is a change in state. So when we find this temperature, when it is constant, so there is a change in state. So when you work out, each box stands for 2. So this is 42, 4, 6, 48, 50, 56. Sorry, 42, 44, 6, 48, 50, 52, 54, 56. So this was 56. And this is 58. And it is between 56 and 58. So that's why it is 57. When the temperature is constant, it means there's a change in state. So we work out its freezing point, and the freezing point and the melting points are the same. Like if I say what is the freezing point of water, that's 0. What is the melting of a point of ice? That's also 0. Now, the specific latent heat of fusion of a wax is 210 joule per gram. So if joule per gram, so mass should be in gram. You don't have to convert into kilogram. The test tube contains 50 grams of wax. So there's a 50 grams of wax. Use figure 3.2. Determine the rate at which a wax is losing energy. Means you need a power. And that is in joule per minute. So first we will find energy. How to find energy? We have the formula latent heat is equals to energy divided by mass. Latent heat is given 210. So this is 210. Energy we don't know. The mass, it's 50 grams of wax. So that's 50. You don't have to convert the unit here. Why you don't have to convert the unit? Because that's given in joule per gram and the mass is in gram. If it was joule per gram, joules per kilogram, then the mass should be in kilogram as well. So 50 is divided here. Other side it will multiply. 210 multiplied by 50. What's the answer? 10,500 joules. So we got the energy. Then what about, we need energy per minute. So we got the energy, but we have to find a time for which it is changing the state. Because the question is, determine the rate at which the wax is losing internal energy as the wax solidified. So as it solidifies, how much time it is taking to solidify? So this is the time at which it starts to change the state at 8 minutes, and it will continue to change the state till this point. And each represent what? 2 boxes. You can see here like from 0 to 4. So it's 10 boxes. So it means each box equal to 0.4. So this is 12.4, 12.8, 13.2, 13.6, 14, 14.4, 14.8, and approximately 15. So how much time it will take to solidify? It started when the time was 8 minutes and continued to solidify till 15 minutes. What is the time interval here? So it took 7 minutes to solidify. And we need how much energy per minute? Because in the question, they ask how much energy is changed every minute. So energy was, you got the energy, that energy was 10,500. And the time, it should be in minute because you need your answer in joule per minute. So time is 7 minutes. So how much energy or power or rate of energy in change in internal energy means power. So it is energy, which is 10,500 divided by time equal to 7. So 10,500 divided by 7 will get 1,500 joules per minute. So first we got the energy, like how much energy is removed, and then we'll find how much time it will take to lose that energy or solidify. But in the question, they're asking how much energy is changed every minute. So that's why it is 10,500 divided by 7. So total energy which it released during this process is 10,500, and it took 7 minutes to do or release this energy. So energy released in this process is 10,500, and it took 7 minutes to release all of this energy. But we need energy release in 1 minute. That's why we divided by time. Is it clear? Discussion?
Mister, at the
Yes,
question he said that losing internal energy,
right.
but in the graph the energy was in constant.
No, no, energy is not constant. Temperature is constant. There's a difference between energy and temperature. Temperature is called the only the kinetic energy of the particles is known as the temperature. But the total energy of the particle is known as the sum of energy of all the particles is known as internal energy. So temperature is constant. What does it means actually? Like when we say you have as you can see in the graph, you was having a liquid, and this liquid solidify and it turned into wax, like solid wax. So as this liquid is changing into solid wax, there is no change in temperature, but there is change in internal energy. What does it mean? Look, if I say you have a particle, the average kinetic energy, when you take average of the kinetic energy, that is called temperature. Okay. So the average energy is not changing. Like example, if this was having 10 joules, this is having 10 joules, this is having 10 joule kinetic. So when you take an average energy for in a liquid state and in a solid state is same, but the total energy is changing. What is the total energy? Because the particle will have both energies. These particles will have kinetic and potential energy both. So example, if I take this particle, so this was having kinetic energy 10 joules, and because it's moving also, so it will have potential energy, example 15 joules. So what happened when the substance is changing the state? The kinetic energy does not change. The speed of the particle remains same, so kinetic energy will remain 10, but the energy which changes is the potential energy. So their potential energy will decrease. Like example, potential energy become 5. So if the potential energy changes, the internal or the total energy will also change, but the kinetic energy remain unchanged. So whenever there is a change in state, whenever the object changes the state, the kinetic energy of the particle does not change. The potential energy change. That's why there is a change in internal energy. Is it clear?
Okay, sure, thank you.
Okay, in this question, um, minute left, so I'll share another link. Just I'll discuss the question and I will explain in the second link. In the lab, um, at a normal room temperature, 200 gram of water poured into a beaker. The thermometer is placed in a water, read 22 degrees. A small piece of ice at 0 is added to a water one by one. The mixture is stirred until each addition until the ice has melted, and the process continue until the temperature by the thermometer is 0. The total mass of the ice added to water is found to be 60 grams. The specific heat capacity of water is 4.2 joule per gram degree centigrade. Calculate the thermal energy lost. So for water, basically what happened in this question, you have a container. Originally, this container is filled with 200 grams of water.